Hello, this is Shamantak, and today we're going to look at the concept of circular motion in easy IGCSE physics. Consider a satellite moving in a circular path, orbiting the Earth. It is always moving with a constant speed. But is it moving with a constant velocity? Let's consider. Velocity is speed in a given direction. As you can see from this diagram, where tangential velocity is indicated by a black arrow, the velocity or the direction is constantly changing. And as velocity is a vector, the velocity is also changing. That means the object is accelerating because if there's a change in velocity, then there's acceleration. That's the definition of acceleration. Acceleration is change in velocity divided by time. So as there is an acceleration, there must be a force that acts on the object. For an object's direction to change, the force must always be perpendicular to the direction of motion of the object. Hence, as the direction of motion of the object is always tangential in circular motion, the radius is always perpendicular to the tangent in a circle. Hence, the force that acts on the object throughout the circular motion is towards the center of the circle along the radius of the circle. This force is known as a centripetal force and follows the formula Fc equals mv square by r, where m is the mass of the object, v is the velocity, the speed of the object, because velocity is changing direction. If we made it a vector equation, it would have been like this. And so it's mv square divided by r is the radius. Therefore, from this equation, we can say that if the mass of the object is increased, then the force would increase. If the velocity of the object is increased, the force would also increase. But if the radius is increased, then the force of the object would decrease. Now let's look at a real question in IGCSE. This is the official mark scheme, but I would rather try to do the question and then see the mark scheme. So this is basically a motorcyclist who is moving along a track. The track remains horizontal but bends to the right, as shown here. When the motorcyclist reaches the bend, she travels around the bend in a circular path. This is very important, that hints at circular motion at a constant speed. Further hints. So let us just draw it if it's required. Velocity is a vector quantity. State how a vector quantity differs from a scalar quantity. The first part is not even about circular motion, but basically vectors have magnitude and direction, while scalars only has magnitude. As you can see, that's what it says in the mark scheme. So, second part. Describe what happens to the velocity of the motorcyclist as she travels around the bend at constant speed. This is exactly what we talked about. The speed is constant, but the velocity changes as the direction of the motorcyclist is constantly changing. Or direction of motion, exactly the same as what we said. Now, the third one is a very interesting question, and I think the first two parts most of us would get right, and the third part requires a bit of thinking. Explain why there must be a resultant force on the motorcyclist as she travels around the bend. There are two ways to go about it. One is to say that, well, we said in part 2 that the velocity is changing, and as the velocity is changing, there must be a certain acceleration. And as the motorcyclist with the bike has mass, by Newton's second law, if there's mass and if there's a non-zero acceleration, then there must be a resultant force acting on the object. That's way one to go about it. Way two is the direction of the motion of object is changing. That must mean that a force is acting on the object that is perpendicular to the object. So there is a resultant force perpendicular to the object. As you can see, it says acceleration, change in velocity, accelerates, velocity direction changes. resultant force perpendicular to motion, or A is proportional to F, which basically is what I told with the F equals ma Newton's second law. Thanks for watching this video, and don't forget to like and subscribe.